Hey everyone, and welcome to a new video, this time about Service Mesh with Linkerd. Now we'll install Linkerd and also install a sample application together with an Ingress controller. But before we do that, let's take a look at why you would use something like a Service Mesh. Why do you want something like Linkerd? Well, it provides features in three big blocks here. The first one is all about observability. You will retrieve signals, metrics from the application, things like requests per second, but also latency at different percentiles, and they're provided to you without you having, as a developer, without you having to instrument the application to provide these metrics. So they come out of the box. A second big part is security. Normally, when Kubernetes services talk to each other, they are doing so in plain text. With mutual TLS in Linkerd, the services will first authenticate each other and then all the traffic will be encrypted. The third big block is all about the network. You can configure retries and timeouts, again without the developer having to do this him or herself. You also have things like load balancing, which is much improved over the standard Kubernetes load balancing features, and also a traffic shifting feature, which is especially handy when you're doing canary releases and you want to shift traffic, like 5% of traffic, to the new version of your application. Now, let's just take a look at how it all works, and we begin with the installation of Linkerd on Azure Kubernetes Service. I already have an AKS cluster up and running. You can see it here with K9S. And it's using version 1.22.6 of Kubernetes. There's nothing installed specifically on this cluster. It's a bare bones empty cluster as it's deployed out of the box with a couple of extra components like Calico and so on, but that's not too important in this context. Now what I'd like to do is I'd like to install Linkerd. There are multiple ways to install Linkerd, and in production you really should look at the documentation and install it via the Helm chart. What I'm going to do here is install Linkerd with the CLI. You have to install the CLI, and if you have, for example, brew on your machine, you can just say brew install Linkerd. I already have this. On Windows you could use choco install Linkerd. And of course, you can also just download the Linkerd executable and have that on your system. It's a single executable that you need. I have Linkerd already installed. And if I check what the version is in my case, Linkerd version, I can see that client version is 2.11.2 and there is nothing installed on my server yet. So server version is unavailable. Now to install Linkerd, the only thing that you really have to do is to do Linkerd install. Now before you do so, it's best to use the CLI to do a check. So I'm going to do a check, and I'm going to do basically a pre-flight check to check if my cluster is ready to receive Linkerd. Let's do that and run this check. That shouldn't take too long. It checks all kinds of stuff. Is your cluster ready to run Linkerd? And indeed it is. I didn't expect anything else, to be honest. Now, we can install Linkerd with Linkerd install. Now Linkerd install just outputs the YAML that you have to submit to the cluster. So if you run this command, nothing happens. You just see the YAML that your cluster should receive. So let's run this again, but now pipe this to kubectl and then apply. So kubectl and then apply, -f and then a dash. Let's do this and start the Linkerd installation on my cluster. That goes to a namespace called Linkerd. We're going to check if Linkerd is now properly installing. We can do that with Linkerd check. Linkerd check will start seeing if Linkerd is installed, and it also waits for things to happen, for things to proceed positively. As you can see here, there are no running pods for Linkerd destination. It says, well, this all has to do with the fact that if I now go to K9S and I go to my Linkerd namespace, which was just deployed, as you can see 44 seconds ago, if I enter this, it will take a while for the pods to come up and be in a running status. After a while, all the pods are in a running state. If I now go back to my other session here, what you can see is that of course the Linkerd check also failed. It timed out because it took a while for these pods to come online. So I can just actually run Linkerd check again. It will check it all. It will see, yeah, Linkerd was properly installed on the system. Now, what I would also like to do here is to install the visualization extension. There are several extensions to Linkerd. One of them is the Viz extension. The Viz extension, you're going to install this the same way you're actually installing Linkerd. You could also do a check here, but I'm just going to say Linkerd Viz install and directly apply it to my cluster. That'll give me a new namespace, Linkerd Viz. And I'm just going to check if indeed these visualization components are coming online properly as well. Let's check this out and see what happens. And this again might take some time. I'm going to go back to K9S, and in K9S I'm going to go to my namespaces again. Now to check this namespace, you'll see that indeed, and I should click properly here, to check the namespace, I'm going to see that there is indeed a Linkerd Viz namespace, and there you see there again at the pod initializing steps. This should not take as long as with the Linkerd installation, so it should be quite quick that this comes online. After a moment, you'll see that this visualization stack is running. And if you then go back to the check command, it's still waiting for the check to complete, but it should normally finish in just a few seconds here. While we're still waiting for this, if you take a look at the different components in the visualization stack, see that it comes with things like Prometheus for metrics collection, Grafana to visualize all of these things, a metrics server as well, but also a web pod over here. And that provides a admin interface, a web admin interface to Linkerd, which makes it quite easy to use and see what's going on into your system. With the visualization extension installed, I can now just run Linkerd and then Viz and then dashboard. What happens is that we'll get a tunnel to that web pod, and that tunnel can be reached via a localhost URL, of course. When I control click on that localhost URL, what I actually see here is the Linkerd UI. Now, we won't go into too much detail in the UI, but what you see here is all the namespaces, and some of the namespaces here, like the Linkerd and the Linkerd visualization namespace, we can see here that they contain meshed applications. So applications that are part of the service mesh. How can you see that? Well, for example, we can go on this Linkerd Viz namespace, and now I see that there are several deployments which have been meshed, as we call it. That means they must be part of the service mesh already. And indeed, we can see this also because Linkerd has seen all the traffic that passes through the pods of these deployment, and it can map out how all the different components talk to each other. So in this case, how all the different deployments talk to each other. And I can directly see the golden metrics. I see the success rate, I see requests per second, I see latencies at different percentiles. And what I can also do is go into more detail and get a Grafana dashboard here. So if I click on the Grafana icon, another window pops open, and now I can see information about the deployment of Prometheus. The same metrics are shown here. So I see success rate and request rate and so on. And I can see, for example, what is inbound to Prometheus and what is outbound to Prometheus. Of course, Prometheus in this case is scraping metrics from many different other deployments. So it goes out to all those deployments and it will connect to it. When we say that an application is meshed, we basically mean that the pods that run your application are meshed. Now, what does that look like? We just seen in the Grafana interface that the Prometheus application is a meshed application. We could see the inbound and the outbound connection and all the scraping endpoint that it goes to. Well, now we're looking at the Prometheus pod in K9S. And when you look at that Prometheus pod, you can see here that basically there are 2 containers in the pod and they are all ready, right? So we have a total of 2 containers and 2 containers are ready. Now, to actually see the containers in the pod, I just press enter in K9S, and here I see the actual application. That's in this case Prometheus. And then of course we have a component that is used by Linkerd to make sure that all the magic happens, right? So that's basically a proxy, and all traffic going to Prometheus is passing the proxy. All traffic coming out of Prometheus, so for example, scraping all the different other applications, the metrics, well, that goes through that proxy as well. Now, what you see here is also a init container. The init container is responsible for making sure the network traffic is adjusted so that indeed all traffic coming in goes to the proxy and all traffic going out leaves via the proxy. So to quickly see if a application or a pod is meshed, you can just check for the existence of the Linkerd proxy container, which is basically a sidecar container in that meshed pod. Now we want to install our own application and also make sure that that sidecar appears. To deploy an application to Kubernetes, you usually use a deployment, so we'll use that here. This deployment deploys an application called Super API, and the image that we use is over here. Now, this is a regular deployment. There's nothing special about that, but we want to make sure that Linkerd, that proxy sidecar that you've seen just a moment ago, is there. Now, the only thing you have to do is you have to add an annotation to, in this case, the pod template, and that's the annotation you have to add. Linkerd.io/inject enabled. Now, I also have a service here for this application, and I also want to deploy this application into a separate namespace. I also have a namespace YAML over here. Now, I'm just using customize to quickly install all of this in one step. So let's deploy this with, in this case, kubectl apply -k, right? It's customized, which is part of the kubectl CLI, and I'm just using dot here. And of course, I'm running this from the manifests folder that contains the customization.yaml. Okay, the deployment is already done. Let's minimize this and see if we can get to our application here. So I'm in K9S. In K9S, I'm going to the namespaces, and I see that we indeed added a Linkerd app namespace. In the namespace, we have our two pods running because I asked for two replicas, and every pod has two of two containers. If I enter on the pod, I see the same thing as before. I have my application now, which is the Super API container. I have the Linkerd init container, which did its thing, rewiring the networking to make sure all traffic going in and going out passes the proxy. And I have the proxy as well. This will now show up in the Linkerd UI. And as you can see, because I deployed my application to the Linkerd app namespace and I meshed the pods in my namespace, it also says, hey, you have 3 out of 3 meshed pods. Probably thinking, where's the third one coming from? Well, the third one is coming from a debug pod that I added. And this debug pod is actually issuing requests to the Super API service. And of course, that service load balances between the two pods behind that service. If I click on my deployment, you will see also the other deployments that interact with it. Now, you might have expected that you would see here the debug pod with incoming traffic to the deployment, because the debug pod is not a deployment, it's a pod, so you won't see it here. The deployment view only shows deployments and the traffic of deployments coming in to Super API. If I want to see the, in this case, what the debug pod is doing, I will have to look at the pod level here. So on the pods list, I click on debug, and there I indeed see that my debug pod is sending traffic to the 2 Super API pods that are behind the Super API service. And out of the box, without me having to instrument the application. I see indeed I have things like requests per second, the success rate, and the latency at the 99th percentile here. If I scroll a bit down, I see indeed here that I have live calls as well. The Linkerd software can of course see it is HTTP. It can see that, it knows this, and it knows I'm doing a get to the index path, right? The root of my API. It counts also the requests, and it gives me the best and the worst response times. I can see what's coming into the debug pod, and I can see what's going out of the debug pod. To enable per route metrics, you can create service profiles. Here you see an example of a service profile for Super API. And this service profile just says, wait, what are the routes to Super API? Now, I made it a little bit silly here in the fact that I'm just saying what are the health and the readiness endpoint that we typically use with Kubernetes to determine the health and readiness of the pods. If I now create this service profile with kubectl apply minus F, so kubectl apply minus F and then service profile, what will happen is if I'm now sending requests to one of these endpoints, I will see the requests to the endpoint. So I will have to make a small change in the requests that I'm sending. So I'm going to do that. So I'm going here in the debug pod. I'm inside the debug pod here, where I previously ran a loop that says while true, do this. I'm going to hit the health Z endpoint. So I'm going to just hit this health Z endpoint. Now, if I go back to the Linkerd UI, what you see now, I actually already changed, is that I now get per route metrics. So here you see it knows about the different routes because I defined them in the service profile, and it said, yeah, well, now in this case, the health Z endpoint is being hit, and I can see the golden metrics at an endpoint level. By default, without a service profile, you get this information at the service level. When you create a service profile, which contains all the endpoints, you get them at the endpoint level. Now, you don't have to create such a service profile yourself. There's a Linkerd profile command that can use a OpenAPI specification to generate the service profile. Now I've added a Ingress controller to the mix. So I've installed Nginx Ingress on my cluster. I have several Nginx pods running. They're fronted by a service of type load balancer, which of course automatically configures the Azure load balancer to bring these incoming requests from the internet to the Nginx Ingress controller. I've also meshed the Nginx Ingress controller pods. I'll show you in a moment how I did that. And of course, to make my application Super API available over the internet using the Ingress controller, I have to create an Ingress resource in my application namespace that does all the configuration at the Nginx level. Let's see how it works in a bit more detail. There are multiple ways to install Nginx Ingress controller, but in this case we use Helm. So you see the Helm upgrade command over here. The thing that is specific for also meshing the Ingress controller is the values file that we are passing here. And in the values file, we add the following thing. We just add the annotation we talked about earlier, this Linkerd IO inject annotation. And for the Nginx Ingress controller, we should do this at the controller pod annotations level. In the Linkerd UI, if I go to the Ingress Nginx namespace, I can here see that I have my deployment fully meshed. So that's the deployment. There are 4 pods in this case in this deployment, and they are all meshed. To make the Super API application on my cluster available on the internet, I have to add an Ingress resource that instructs the Ingress controller to do the thing it needs to do to accept traffic. The most important thing, of course, that you have to have a host name, and I'm using nip.io here, which is a nifty helper service where you can just put your IP, this is the public IP of the Ingress controller, in front of, and then any other random name that you want. So this is my host name that I can use to reach my Ingress controller on this IP over here. And if I use this host name, that will bring me to the Super API service on my cluster, which is using port 80 here. This Ingress definition also turns on affinity, namely cookie-based affinity. That's the only type of affinity that Nginx Ingress supports. And we also use the persistent affinity mode here. In the browser, I navigate to the host name I just talked about, and I didn't configure TLS, so it's just unsecured HTTP traffic. Now, because of this cookie-based affinity, if I keep on refreshing the browser, it always will be the same pod that answers. It switched in the beginning, but that's normal because I changed things. But now it keeps on going to this 216 address. That's actually the IP address of the pod, and I retrieved that IP address using the downward API in Kubernetes. That's not too important. You can look up in the YAML in the source files that you can find the link to in the description of the video. You can look up how that is done. This actually means that we are not using Linkerd's load balancing here. And what happens is the Ingress controller is asking the service about the real IPs of the pods that are behind the service. And then the Nginx Ingress controller is really using the pods directly. It bypasses the service entirely. It also means that the Linkerd load balancing is not used in this case. To use Linkerd load balancing instead of Nginx Ingress load balancing, in this case with cookie-based affinity, you can actually just add the following annotation at the Ingress resource level. So it's not a general setting, you decide on this per Ingress. And in this case, we tell the Ingress controller to send requests to the service directly and not to the pods behind the service directly. Now, in this case, the affinity setting is not appropriate anymore. You won't have affinity in that case. So I'm going to just remove this here from the settings. I'm gonna save this and then apply this Ingress YAML to my cluster and see what happens when I now go to the browser and refresh the screen. When I refresh the browser now, at every refresh, I'm getting a new IP. So we end up at different pods there. Of course, this is no absolute proof that we now have Linkerd load balancing at work. I could have also just removed the cookie-based affinity from Ingress Nginx, and you would then also do that in this case. But we can be sure that we are sending now all the traffic from the Ingress Nginx to the service, and that more of the features of Linkerd are in effect now. Now we'll just hit the Nginx Ingress controller, and I'm also going to use the flaky endpoint that my service has. That endpoint in 10% of cases will respond with a error code 500. So we can also see in Linkerd that we get some errors back from our services. So I'm going to use hey in this case, and I'm going to hit the service relatively hard from my client here, and then see what we get in the Linkerd UI. Let's go to the Linkerd UI here, which of course is here, and we go to Ingress Nginx. And what we see now is indeed that we have traffic coming into the Ingress Nginx controller. We also see now that the color has turned somewhat red because we also have these 500 errors here. So the success rate is not 100% anymore. And of course, this Ingress Nginx here is sending the requests to the backend, which in this case are the 4 Super API pods on my cluster. And they're of course the ones that respond with the actual 500 error here. When I go to namespaces and go to my application namespace, I also can see here at the Super API level that the success rate has dropped to somewhat of 90%, which is correct because in 10% of cases the flaky endpoint will respond with a 500 error. I can go to the Super API deployment, and I can see here as well what's going on, and also what we're getting as incoming requests here. Now, of course, what you get here is, if you go to the namespaces, the advantage now of having Ingress Nginx meshed, I think it's clear. We get information about success rate and request per second and latencies from this Nginx Ingress Controller. What we also get is that the traffic between the Nginx Ingress Controller and, in this case, the Super API pods, that traffic is secured with MTLS as well. So I'm getting those two features out of the box, and well, we hope that also, of course, the Linkerd load balancing is in effect, which also takes into account things like response times of the endpoints, etc., etc. I'm going to end it here. I hope you have seen now how easy it is to install Linkerd, how to mesh your own application, make it part of the service mesh on your cluster, and we also meshed our Ingress controller so we can secure the traffic end-to-end and also get interesting metrics from the Ingress controller. I hope you liked it. See you some other time. Bye bye.